Welcome to this YouTube channel Learn Quick. I am Dr. Sharif. In this video, we will learn how to draw the isometric view of a cone resting centrally over a frustum of hexagonal pyramid. This video is made based on viewers' request from our previous lesson on isometric view of a frustum of a hexagonal pyramid. Here, the additional task is to place a cone centrally over a frustum and represent the entire combination as a single isometric view. This exercise is simple, interesting and very helpful, especially for the beginners who are just started to learn isometric projection on combination of solids. So let's get started and learn step by step together. Before we begin drawing the isometric view, let us first understand the given solids by drawing their orthographic views. In this problem, we are dealing with a cone resting centrally over a frustum of a hexagonal pyramid. Drawing the orthographic view before attempting the isometric view helps us clearly understand the shape, orientation and relative position of each solid. This preliminary step is especially useful when working with combinational solids as it reduces confusion during the isometric construction. For most truncated solids, drawing the front view and top view is considered mandatory, as it helps in visualizing the truncated shape and dimension after truncation. However, for the given exercise in this video, since we are required to draw only the isometric view, this step is technically optional. If you are already experienced and comfortable with visualizing solids in 3 dimensions, you may directly proceed with the isometric view. That said, for new viewers or beginners, it is strongly recommended not to skip this step. Drawing the orthographic views first will build a strong foundation and make the isometric drawing process much easier and more accurate. If you feel unsure about the basics, you can take a quick look at our previous lectures on projection of solids and isometric view of frustum of hexagonal pyramid. The links to these videos are provided in the description section below. Reviewing them will help you follow this drawing more confidently. While drawing the orthographic views, you may also choose to add dimensions. Dimensioning the front view and top view further improves clarity and ensures the proportions are maintained correctly while transferring the details into the isometric view. It is also important to note that if you are appearing for an examination or submitting an assignment, the requirement to draw the front view, top view and proper dimensioning is usually specified clearly in the question paper or the marking scheme. In such cases, skipping the orthographic views may result in loss of marks even if the isometric view is correct. Now let us move on to drawing the isometric view of the solids using the box method, which is one of the most reliable techniques for constructing accurate isometric drawings. The first step is to draw the isometric axis. Remember, in an isometric drawing, the 3 principal axes are drawn at 120-degree angles from each other. Once the axes are drawn, we construct a reference box. This box represents the overall dimension of the solid and provides a framework within which we can accurately position all other features. Usually, the dimension of this box are taken from the orthographic projections we have already drawn. In this exercise, the top and base hexagons of the frustum have been enclosed in the box and their corners are labeled A, B, C and D. The cone is positioned centrally on the frustum and its base appears as circle in the orthographic projection located exactly at the center of the top hexagon. If you want to strengthen your understanding of this method, you can refer to our previous lecture on the isometric projection of a cube, which explains in detail the 120-degree angles between the isometric axis and also highlights the difference between isometric view problems and isometric projection problems. The link to that lecture is provided in the description. Now, keeping the corner B of the box nearer to us, we start marking the corners of base hexagon inside the box. Accuracy at this stage is very important because all subsequent construction depends on these points. Next, we carefully position the top hexagon. This is done by measuring the distance between the sides and corners of the base hexagon and transferring these measurements along with vertical edges of the reference box. The top and base hexagon together define the frustum of hexagonal pyramid except for the portion where the cone will sit. Once the top hexagon is accurately placed, we begin developing the isometric view of the frustum. At this point, we do not draw the portion where the cone will be positioned as that part will be overlapped by the cone in the final view. Now we move on to the cone. Start positioning its base circle carefully inside the top hexagon. To do this accurately, measure the distance from the sides or corner of the hexagon to the circumference of the circle, ensuring that the circle is perfectly centered. For a detailed explanation on drawing circles in isometric view, I recommend watching our previous video on isometric view of a cone or isometric view of a cylinder. After positioning the base circle, we draw the visible lines of the cone. Typically in isometric projection, the apex is joined to the circumference of the base using straight lines, giving correct three-dimensional appearance. Finally, we complete the visible lines of the frustum of the hexagonal pyramid, excluding the portion hidden by the cone. The edges that are obscured by the cone are left out or can be shown as hidden lines, depending on the requirement of a drawing or assignment. Thank you for learning with Learn Quick. If this video helped you, like this video, share and subscribe, and I will see you in next Learn Quick video.